Hi folks, we're going to solve here page 420, number 21. So here we have two forces with equal magnitude, and they give us that the angle between those forces is 60 degrees. And they also tell us that the resultant force has a magnitude of 20 newtons. Okay, and they want us to find the magnitude of these original equal forces. Okay, so again, start with a diagram. So I don't have much information about these forces, at least in terms of their magnitude. I just know that they're equal, and we have the angle between them, which is 60 degrees. Okay. What they do give us, though, is the magnitude of the resultant, so that represents the sum. So again, to show the sum, I'm going to put them tip to tail. So I'll take this vector and just move it over, and this will represent the sum, and that has a magnitude of 20. Okay, and what I want to do is I want to find the magnitude of these two vectors, in other words, the lengths of these two sides of the triangle, which of course are equal. Okay, now notice here the angle between them is 60. That's not the angle that's inside the triangle I'm going to be working with, but these two angles are supplementary, so this is just going to be an angle of 120. Now the first thing I notice is that I only have one side and one angle in this triangle, which is normally not enough information to work with a non-right triangle. But notice how these two sides have the exact same length. Okay, so I'm going to use, I can't use sine law. There's no option for that because I do need two angles. Actually, sorry, I could use sine law because obviously if this is a an isosceles triangle, I do know these two sides. So in fact, you know what, maybe we'll do it both ways. Okay, what I can do is I can use cosine law, okay, which just gives me that 20 squared is equal to x squared plus x squared minus 2 times x times cos 120. Okay, this is, I guess, probably the tougher way of doing it, but since that's what I thought of, let's do it this way. So here we have 400 equals, so this is just going to be 2x squared. So here we just have to calculate 2 times cos 120, 2 times cos 120, which is just -1. Not surprising, since cos 120 is going to be equal to half. Okay, so here we have minus, negative x squared. So in the end, we just have to solve 3x squared is equal to 400. Okay, and so x is just equal to the square root of 400 over 3. Okay, I'm only taking the positive square root because it's measuring a magnitude, which is going to be positive. So square root of 400 divided by 3, there we go. We have 11.55. Okay, which is exactly what we were looking for. Now, again, this is probably the tougher way of doing it, and let's do it with sine law just to see that we get the same amount. Okay, so if this is 120, that means these two angles must add up to 60, so they must each be 30. Okay, so what I can do here is I can just do x over sine 30 is equal to 20 over sine 120. Okay, and so here x is just going to be equal to, well, what do we have? 20 times sine 30, okay, divided by sine 120, and lo and behold, 11.55. Okay, and of course this is in newtons since it's a force. Okay, so obviously this was simpler. This one here, for some reason, is the first one that came to mind. But in the end, this question is all about placing the vectors in the correct location. So when they give us the angle between them, place them tail to tail. But when you're working with the addition, just move a vector over to place them tip to tail and make sure you're working with the correct angles. Okay, that's it for this one.